Yeah, we're having a surprising amount of difficulty with this, but this just tells me something about the fact that almost everything you've done with graphs has been with a calculator, and you don't really understand graphs very well. Okay? No offense, we'll fix that. Okay? And we're in the process of fixing it. So, if x is 10, then f of x is f of 10. And f of 10 is how far you got to go from 10 to get to the graph. The displacement from the point 10, 0 on the x-axis up or down to the graph, right? And then, well, what is this value? Well, it doesn't matter. This is f of 10. Okay? So this line segment has length f of 10. Also, this point up here, what are the coordinates of this point? Yeah. Coordinates of this point are 10, f of 10. Okay? And we could estimate f of 10. The y-coordinate of this point is f of 10. Right? Because the y-coordinate here is the same as the length of this, because this is a square, I'm in a rectangle, all these angles are right angles and all that stuff. Okay? So any question or argument about that? Most of you had that one. Okay? Now, if you keep your wits about you and think about what f of x plus delta x means, well, what do you do if you got numbers for x and delta x and you want to find f of x plus delta x? What's the first thing you would do?
Plug in
Plug in what?
5 and your f of x.
No. No, you don't have a distributive law of function notation over addition, which is kind of what you do. But there's a tendency for people to do that, so it's not an unusual thing. Okay? Now, if let's say f of x equals x squared, and x is 5 and delta x is 10 and delta x is 5, just like it is here. Let's say this was the squaring function. It isn't, because the squaring function doesn't have a curve that looks like this. Could well be a quadratic function. If this is depth versus time, maybe it is. Okay? Or maybe this is a pendulum thing, and y has a different meaning. Whatever the meaning is, okay, go back to this. So if f of x was equal to x squared, just to take a really simple function, then what would f of x plus delta x be if x is 10 and delta x is 5?
F of x plus 4 delta x.
Again?
F of x plus 4 delta x.
Plus 4 delta x? Is that what you said?
Delta x.
No. Okay, here, let's just do some function notation, because y'all are real good with that. Okay? And we're going to get real good with this. Okay, x is 10, delta x is 5, f of x equals x squared. Right?
Where did we get that?
Huh?
Why
I just
is
wrote
x
it down.
squared?
If f of x is x squared, then we want to see what f of x plus delta x is, right?
Okay, so for mine, since I estimated it to be 4 because it fell right on the line of 4,
No,
can I go ahead
that
and
was for
plug
this
it in?
graph. This graph does not correspond to x squared. So I'm saying if f of x was x squared, then what would this be?
X plus delta.
Well, first of all, x plus delta x is x plus delta x squared, right? Because that's what function notation tells you, if this is f of x. Okay? So I can say if this then find this. Let's make a complete statement out of it so it's less ambiguous, okay? So if x is 10, delta x is 5, f of x equals x squared, then find f of x plus delta x. So there are a number of things you could do. You say f of x plus delta x is x plus delta x squared, right? Then what would you do?
10 plus 5.
I'm sorry, somebody's walking the hall, somebody's rolling across the floor. A little louder?
10 plus 5.
Okay, I would substitute the values of x and 5. Or maybe I just write out what the square of that expression is, then substitute them, but it's much easier to substitute them and just start dealing with numbers, right? Matter of fact, we could have done that right here. Okay? So that equals and that's 225. Again, everybody should know that square. I know most of you don't, so it's okay, but think about that for the future. Okay, now, that's one way I could have done it. I would have gotten 15 squared, and that comes out 225, right? More to the point, for this problem, I could substitute 10 and 5 right here, couldn't I? So where I substitute 10 and 5 just depends on what I want to accomplish. Okay? I could wait to substitute it here. I could even expand this and then substitute it, right? And there are times when you'd want to do each. The most direct thing, it would be to do the substitution right away, since we have numbers for x and delta x. So this is f of 15. And in this case, that's 15 squared, and I'll write it down here, I didn't have room to write it there, but it's 225, but that's not important, okay? But that's what you would do, right? I mean, if I told you f of x equals x squared, and x equals 4, and delta x equals 2, and ask you to find f of x plus delta x, I think everybody would be able to do it, okay? I think you would have before I explained this. So I'm just using an example here that I think you should understand. Now the point is that we can evaluate x plus delta x, right, at first, and we get f of 15, right? Now over here, we've got the expression f of x plus delta x for x equal 10 and delta x equals 5, right? So what's f of x plus delta x? Isn't it still f of 15?
Yeah.
But see, this is not the squaring function. This is a different function. We don't know what the function is, but whatever it is, okay? Going to write 15. F of x plus delta x is f of 15. Okay? So what we're looking for on this graph is something to represent f of 15. Okay? So we go to 15, we do this, and the length of this segment is f of 15. Okay? And we could make an estimate. It doesn't hurt to do that. Since we've got a scale, we might as well. Well, f of 15 is just what we get here. Okay? And we could even say the f of x for our question is f of 10, and f of x plus delta x is our f of 15. So automatically, on our graph, we're going to make that sketch. Okay? Everybody understand what we do and why? We do f of 10 because that's what x is, and f of 10 is just from here up to here. We do f of x plus delta x, and x plus delta x is 15 in this case, so here's our f of 15. Okay, then we can make our trapezoidal approximation here, or if we prefer, we could just do a fundamental triangle. Either way, we're going to get an expression for the slope, right? And again, just as it was over there, rise is f of x plus delta x minus f of x. Here's your f of x plus delta x, here's your f of x. Your rise goes from here to here, so it's this minus this. Your run is delta x, so your slope is f of x plus delta x minus f of x over delta x. Now, f of x plus delta x minus f of x is f of 15 minus f of 10. And this is f of 15 minus f of 10. Numerator is f of x plus delta x minus f of x. And you're dividing that by delta x, which is 5. Okay? Now, make your own estimate according to your own graph. What is f of 10? What's the value? Okay, now some of you already estimated that. Okay? But make your own estimate in your graph of f of 10 and make your own estimate of f of 15 and see what this slope would be. And then we'll talk about interpreting it.